My name is Ashok. I have over 20 years of experience in technology. Uh, the last 3.5 years to 4 years, I've been predominantly spending on big data and analytics. So I'm very happy to be presenting the next hour on some of the algorithms that is used widely in data science. So I'm sure you will find this topic quite interesting. So I also have a hands-on towards the end, a lab session. So I will do that as well. So top 5 algorithms used in data science. So we have picked the ones which are quite popular and which are widely used. Right, friends? All right, let's get started. End of the session, you know, this is what is data science, what does data scientists do, what is the nature of their job, top 5 data science algorithms like decision tree, random forest, association, rule mining, which is your that's one of the popular algorithms too, linear regression, and k-means clustering. That's very widely used, right? That's one of the clustering algorithms, and there are so many algorithms, friends. So it is not to, I don't want you to limit yourself or constrain thinking that these are the only algorithms, but these are very popular ones what we are talking about, right? So let's move on. I'm sorry. uh, this is a very cliched statement, right? Like data scientist, sexiest job of the 20th century. I think everybody talks about it now, right? It's a pretty cliched old statement. So, but you should know it, because that's data scientists are going to be in demand. They are already in demand, by the way, and they're going to be more and more in demand, right? So, and we all know data is coming from various quarters, right? So data is just not restricted to coming from a very structured source. Today the data is actually coming from myriads of sources, right? So we are talking about sensors, we are talking about logs, we are talking about social media, we are talking about wearables, we are talking about all the devices, right? So we have data coming from different pockets, different sources, right? How do we, and this is only going to multiply further and further, right? So this is never going to come down, right? So when there is so much of data collection happening, there needs to be a process to analyze the data, right? So the data analysis and data science, it is only going to be growing further, right? So we will have lots and lots of scope as we speak, right? In the years to come. At least I see a very bright future, at least for the next decade or so, right? So it says, okay, let's move on. Data science is nothing but extracting meaningful and actionable knowledge from data, right? So, like I think you would have also heard about one thing, right? In 60s, people are talking about the 40s, 30s, in 1930s, 40s, and all, there was a gold rush, right? You all would have heard about that. People were just fighting for gold, and people were even lots and lots of people actually went to California to look for gold, right? So California was actually came into it became more popular. Now, and 60s, 70s, it was all black gold, right? People are talking about crude, especially in the Middle East. And today, data is the gold, right? If you know how to make out, how to make meaningful insights out of that, it is worth the weight of gold or even more than that, because a lot of critical decisions that can drive the economy, or that can drive the direction of a company. A lot of things actually depends on how we analyze the data, how smartly we analyze the data, right? So it says you have less of a chance being killed by a falling piano than you being adopted by Angelina Jolie. Okay, it's just a statement. So yeah, I mean, see, there is also one more thing, right? So whatever people say that other than parents, you don't trust anything but data, right? So that's another thing people talk a lot, right? So there are very few, I would say, Steve Jobs, who knew how the market would respond, right? I mean, he came and decided what the customers wanted, rather doing an analysis of what the customers would need. He said, this is what they would want, right? So that was the confidence he had, and he changed the complete landscape, right? So with the iPhone and all that. Um, But the point is, that's a pretty 1 in a billion case, right? We are not Steve Jobs. I mean, I don't want to say that. I don't want to generalize that. But the point is, there are very few cases like that. But predominantly, we go with data, which is going to be a trusted thing, right? So anything that happens with the data, right? We are like, we want to go with the data so that there is a higher likelihood of, doing things correctly. Okay, this is again, data scientist, people definitely want to jump in because, we are talking about, a sexiest job with high pay package and all that stuff. And it's not going to be easy to become a good data scientist, right? In a short while, it actually, they are very highly paid people. At the same time, they come with lots and lots of, uh, I would say talent and knowledge, right? So they are not like, they know enough statistics than any software engineer. I mean, they are not statisticians per se, but they know enough statistics. Okay, because they need to work on algorithms, they need to work on lots and lots of, formulae and algorithm, and they need to write out all those how to optimize the algorithm and all that. So that is one thing, and they are very good at software engineering too than any statistician, right? So it's not like they are just pure statisticians. They know enough software engineering principles also, right? So they are blessed with multitude of skills and they love playing with data, meaning they, given the data part, right, they just love to, completely play with it and, arrive at meaningful insights, right? So that's like they are data scientists essentially, right? So it comes with truckloads of experience to become a good top-notch data scientist, right? There are a lot of folks still in the world, they all claim to be data scientists, but, to reach a stage, to really come to a level, one needs to have worked in serious projects and serious implementations where they've really proven the skills. I mean, let it be in any field or any profession for that matter, but data scientists, they really come, they are experts in that. So if you look at that, right, data science in general, data engineering, domain expertise, they have enough domain expertise too. Like BAs, they are blessed with a lot of domain expertise, right? So they know advanced computing, they know how to optimize the algorithm, they can write, they can probably, find out the best algorithm that would suit the business and things like that. They know enough knowledge and visualization. And most of the data, some of the leading data scientists, like chief data scientists, they're all in the, they will be in the board and all that. So they report to CTOs and, many of them are like very highly placed and highly paid as well, right? So they have knowledge on all these domains, what we are seeing here. And if you look at this arsenal, data architecture, they know enough big data, machine learning, and they know what is a machine learning lib, Spark, Mahout. Mahout is one of the frameworks that is an open source from Apache, right? And they know how to use Python. Python is a widely used language, right, in data science. So R is again one of the leading tools as well, right? R and Python are, and SAS, there are a few other things available, right? So they are well versed in these things as well to analyze and all that, right? So different machine learning algorithms is a daily work of a data scientist. It becomes very important for a scientist to have a good grip on machine learning algorithms. They are just not, they are good and, they have this mathematical, statistical aptitude, and they have good eyes and ears for data architecture. They know what Hadoop, big data, and all that. They know how to analyze the data. They know how to optimize the algorithms. They know how to write new techniques, marrying some of the existing algorithms, right? So they know how to do extensive analysis, deep down data mining, all those things, and they are well versed in machine learning as well, right? So it's a combination of everything. So it's not something, that can be mastered quite easily. It takes some time, right? It takes years to, become a very good data scientist, right, friends? So moving on, machine learning, what we are saying is a method to teaching computers to make improved predictions based on data. It's a huge field with hundreds of different algorithms for solving myriad different problems. So, I mean, machine learning it's basically a branch of artificial intelligence, right? It's like, it's like, study of systems that can learn from the data, right? So it is used in different things. Today, most of the machines, in US, initial diagnosis and all, it is done by the machines, right? In many leading hospitals, right? So they know what are the usual symptoms, what is the diagnosis, and what can be the medication, right? So these are all the things where machines are actually slowly replacing the humans, right, on a regular basis. So and it can, it is making more and more penetration, and we all know, just to give you a small perspective, how many people, have heard about Deep Blue? Deep Blue in chess. Has anyone heard about that? Okay, no? All right. Sorry guys, a little noisy out here. Okay, well, Deep Blue was one of the projects that was done by IBM back in, I think, late 90s. So then came Fritz. These are some of the chess engines, right? So today, if you go to, if you're a chess uh, person, I think you will see a lot of, there is one of the most powerful engine called Komodo, right? It's in the name of Komodo Dragon, right? So that is like, it plays with one, it'll play with one piece, missing piece, right? With an established grandmasters, yet it is able to, defeat them. So it is becoming powerful, more powerful. Even Kasparov, one of the yesteryear's, grandmasters, and he was probably the best player at one point. So he lost to this Deep Blue chess, right? So I mean, the more and more they are trained, right, the more and more they become better, right? All these are like, in a way it's machine learning, right? So the idea is, the overall goal is to devise learning algorithms so that does the learning automatically without much of human intervention or assistance, right? There are various models which we have listed down. So there are various models available. Okay, so friends, before I move on, so I just gave a very small introduction. So there are one question like, I'm Java, 6 years. For me, is there any chance to get into data science? So I think I'll take the questions towards the end so that, I'll cover whatever I should cover. But, since he has asked me earlier, I just want to answer this quickly. So I think, 6 years, there's nothing can stop you from learning whatever you want to learn, right? So learning is a continuous process. So that's a very philosophical answer at a very high level. My point is like, you can definitely get in because Java, you can become a data science, you can get into data science because data science is just not statistics and Python and all that, right? Or R for that matter. There's a lot. You still need to do a lot of data analysis that can be done using big data technologies, using Java itself, right? Lots and lots of possibilities are there. Things don't stop at one point here, right, friends? All right, moving on. Beneficial. Do you know what is actuarial science? Actuary. Uh, Bijon Guha. Sorry, Bijon. I'm sorry. I'm ignorant about what you're asking. Actuarial science. Actuary. I'm sorry. If somebody knows it, please share it. Your thoughts. Sure. All right. Moving on. I'm just going to show you very simple. This is one of the algorithm, right? Decision tree. How many people have seen the flow chart decision? Oh, it is in. Arun Kumar says it's related to insurance domain. Okay. Pricing models. Oh, really? Actuarial science. Okay, that's good thing, friends. Some perspective is being shared. Yeah. Sorry about my ignorance here, but good that we are learning. For me, it's a learning too. All right. So, friends, decision tree. If you look at it, this is my training data, right? So, if you look at it, right? So there are like 14 records here. Okay, there are 14 records here, and the age is like what we are giving. Some of the rules. The age is less than 30, less than or equal to 30. The income bracket is pretty high, right? I'm getting the record number 1 here. Is he a student? Yes or no? No. And what is the credit rating of that person? Fair. Does he buy that computer? No. Okay. Here is a decision we are making, right? Does he buy the computer or not? You given these rules, right? A person with less than 30 years of age who falls in the high income group, who is not a student with a fair credit rating, is not buying the computer, right? Similarly, there are so many rules here, right? Less than or equal to 30, high, student is no, excellent credit rating, again doesn't buy the computer. Again, if you look at it, 31 to 40, high, no, fair, yes, fair credit rating. So what, I mean, this is like, these are all the, records we have. So now, for this will help us to make a decision, looking at the data set, right? So greater than 40, medium, no, excellent, no, right? So if we need to formulate, I just want to show you a very simple thing. So there are like 14 records overall. So it has been branched out into 7 apiece. The reason is, 7 people have opted for yes, they will buy the computer. Class is, the classification, right? I mean, they are making a decision here, right? So here, they are the root node, right? The decision tree, when they are taking, the root node is actually student, right? Student. If the student is no, these are all the things. There are, there are, if we go back here, right? There are 7 records that are student no, right? If you look at it, right? 1, 2, 3, 4, 5, 6, 7. And similarly, there are yes, 7, correct? This is how we have divided, okay? So if you take the student, no, so that is like, it is classified this way, less than or equal to 30, high, fair, no. Finally, they are buying or not, okay? This is what we are trying to determine, right? So no, yes. Similarly, so the next step, right? No, we are breaking that into high and medium, right, friends? So here, there is like high and medium. There are 2 categories here, right? We need to branch it down further, right? So we are branching it down further. So we are saying credit rating fair, excellent, fair. The class is no, no, yes, right? Again, medium, okay? Fair, fair, excellent. We are getting low income. I mean, similarly in this side, right? We are taking the income again, low, medium, high. With the credit rating, with the income group, low, medium, high, right? So again, we are classifying, we are branching it, we are going to the next level here, right? We are splitting that. How do we decide which, excellent question, Ansh, I'll come to that. How do we decide which column to branch on? Okay, I will want you to answer maybe after I explain this, right? That's a good question, nevertheless. So step 3, we go with the income. Okay, because I mean it's just an expansion of the step 2, because medium, if you look at it, right, here the decision is made, right? Yes, yes. So there is no further branching. The branching is needed once you have a mixed answer here, right? This is like a concrete answer, yes, and here is also a yes. So these two are decided. So this needs to go on further, right? So that's what we are doing. So now yes and yes, we have arrived, right? So what we are trying to say is, if the person is a student and if the income group is high or medium, they are buying the computer, right? Correct? So that is something we are making a decision. Similarly, these things, they are not done yet, right? So we need to go step 4 again. Look at that. So then we take age and credit rating, right? Age we get. So again, this becomes no, this becomes yes. So there is a yes and no, no and yes, and this is a yes, this is a yes, no, right? So the things which are being decided here is this and this and this, right? So this, and this needs to go in further, one more iteration, right? So these 3 things have to go through one more iteration. So the yes, no, yes, this is coming out clearly. Okay, now this is like, again we have branched it. Okay, this the things which we saw, right? Greater than 40, 31 to 40, credit rating excellent, income group is medium, if you look at that, right? Sure. So this one we have split that and we have come to the final decision, right? So just a second. So So these are all the classification rules. I'm sorry. These are all the classification rules we could come up with based on the data and based on the date, I mean, the branching what we did. Now, Ansh has asked a very important question. How do we decide which column to branch on? In fact, I will put the question, in fact, I'll put it one more step even higher than that. We took student as the root, right? So what makes you think that student should be the root? Why not we take, let's say, income group as the root? Why can't we take the credit rating as the root? Okay, why can't we take age as the root? Okay, and and again, coming back to Ansh's question, right? How do we decide which column to branch on? Can someone answer this, friends? I'm sorry to put it back on you, but just give it a shot. Otherwise, I'll anyway. Uh, can you just try that? I'll just wait for maybe just a minute. This could be based on different attributes shown in the screen. Based on information gain, okay, fantastic, Pratik. Yeah. Entropy. It is the best division of data. Okay, I think these are all valid answers what I'm getting. Okay, but not to complicate, but he is correct. Pratik is correct. Information gain. Yeah. So entropy is the, if there is any, what to say, the data is not so great, right? So let's not even get there. But what I try to convey is the way we want to split. See, for example, friends, I will give you a very simple very simple example, right? Suppose I want to give you, like, you want to pick, let's say, you know, suppose you are the, you are the class instructor, right? You want to pick two people who are going to, who will be representing the school for the national quiz, right? I'm just trying to think of an example here, right? Okay, national quiz competition, right? You want to pick a couple of folks from your team, from your class, right? The class consists of 30 people, right? Now you want to make a decision, right? You want to make a decision. Now there are ways to do that, right? There are, like, you want to look at their science grades, right? Whoever got 90 plus, right? That is one thing. Okay, and and let's say that there are, 7 or 8 guys in that. Okay, the other thing is, other criteria is somebody who should have, who is, pretty good in, let's say, problem solving skills. Somebody who has done, uh, you know problem solving and language skills. Let's put it that way, right? Somebody who's very familiar with Hindi and all that. Okay. Um, I'm just trying to give a vague example here. Sorry about that. What I'm saying is, so if this is the way, right? If there are very few people who know Hindi or, problem solving skills, right? So, and there are like 7 or 8 people who have scored more than 90 in science, right? So will you take the science thing first and go with this, or go to the lesser thing, like 2 or 3, where you would get the number of count is 2 or 3. Which approach would you take, first or second? Friends, did I make sense here? I mean, I was trying to give you an example. What I'm saying is, okay, what I'm saying is here, the point I'm trying to make here is the way we can arrive at a decision quickly, right? So if I have something like, if I need to pick up somebody who has got blessed with great problem solving skills, out of the 7, let's say that 2 or 3 are exceptional, right? So I will go through that so that I can straight away filter those 4, right? Straight away filter those other 4 and move to a decision quickly, right? Right? So instead of going in a very roundabout way. So that's what, Pratik is trying to say, information gain and all. I think it is definitely, that comes into the picture when you actually try to determine even what can be the root node here, right? Okay, so you need to find out, based on different root nodes, right, which can make, the higher the information gain, right, the shorter the thing is. That's probably the most effective way to do things, right, friends? So I want you to remember that. Sorry, my example was not all that great, but I just tried to pick some random example. Sorry about that, but nevertheless, is my point understood here? Are you all getting what I was trying to say, friends? Okay, all right. Glad you got the point. That's what I wanted to Say, all right, thanks. Okay, this is another algorithm here, random forest. Okay, so if you're looking at it, right, it says, suppose you are indecisive about watching a movie. Okay, it says Edge of Tomorrow, this is one of the movies. You ask your best friend whether you like the movie, or you ask group of your friends. What is your preference, friends? I just want to find out from you as well. What will be your approach? Okay, Bijon says group. How many people think that you should ask your best friend? Lakshman says I'll ask my best friend. Okay, all right. So there are divided opinions here, but generally, friends, let's say you want to make a critical decision, like buying a car, right? Will you ask your best friend or will you ask group of friends? Which is better in your, I mean, your personal preference is something I agree, but which is better? Which has got a higher success rate? Which has got a higher success rate is all I'm asking. Okay, there's one more person says I want to watch. I go even though it was a flop movie. Okay, all right. That's your personal choice. Group of friends. Indrajit says group of friends. See, friends. I mean, what I'm trying to convey here is the if you're buying a car, if you're making a major decision, right, or you want to invest on something, you want to buy something, or you want to get some opinion, seek some opinion on somebody's medical or somebody's health, right? All those things, right? We just don't bank on one person. Of course, we are looking at somebody who can give us the right one, correct? But we also, even in the doctor's case, right, we always seek second opinion and all that, right? Second opinion, third opinion, whatever, right? Group of friends, the success rate is higher, right? We don't bank on one decision. Random forest is all about that, right? If you understand that, right? So instead of ask your best friend, right? You're like asking your best friend here, is it a true incident? No, no, you will not like the movie. Does Emily's Blunt cast in that? Is she the main lead? No, no, yes, you will like the movie. So there are there are multiple decision trees here, but what we are trying to say is the consolidation of various decisions coming from different decision trees within the random forest. So suppose I have four people put up their, four of my friends say yes, hey boss, you go and watch this movie, it's pretty good, right? Four people are saying, one person says it's a stupid movie, right? But would you go for the movie or not? Most likely you will still go and watch it, right? Because you feel that it is 4:1, so in favor of the movie, so you're okay with that. So because they'll all you'll always get a mixed feedback for anything, right? But overall, you will try to assess that and feel that okay, this is like 4:1 or 4:2. So random forest is again, if there are four people say that yes, you can watch the movie, and two people say no, you still go with the majority, right? So that's basically it here. If you look at it, might not always generalize your preference very well. It may even an overfit can happen. So more accurate recommendation, you ask a bunch of friends, that's what we said, and they vote on whether you like a movie. The majority will decide the final outcome, right? So again, friend one says, so you're making a decision, no here, yes. So this is like evened out, right? So here, yes, 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 right? There are three yeses. Okay, friend two. Friend 3, there are like one no, correct? So this is like how many yes versus how many no's here? 1, 2, 3, 4 versus 2 no's, right? So you will probably go watch the movie. I mean, friend 3 is like I don't know, hates Tom Cruise, must be really crazy here. Okay, so it is like you will go for the movie, right? In this case, 4:2. So this is like random forest is nothing but it's like an ensemble made with many decision tree models, right? So ensemble is like it combines the result from different models, correct? So usually better than, so it has got a higher success rate than a decision tree, right? Because it is like coming from different you know decision trees. It's a combination of decision trees. So the algorithm is definitely, it has got higher accuracy. It is believed to have higher accuracy here. Friends, is that clear? Okay, all right. So just wanted to get it. All right, friends. Thanks for clarification. All right. So association rule mining. So this is, I think it's just one slide or a couple of slides here. Okay, I'll just talk about it. Classification. Yes, that's right, Yaneshwar. Yeah. So if you look at it, right, which items are frequently association rule mining? I think I just want to talk about it a little bit here. So um, the thing is, you know, the people who bought milk, they also, you know, they also buy bread and cereal, or the customer one, you know, these are all shopping baskets, right? So this is like various shopping baskets, they're uh, doing this, right? So from this you can mine the data and figure out the association between various items within a basket, right? So you will come to a conclusion, like, you know, if you assess things, right? So because there are lots and lots of science behind product placement in a shop, and also, you know, how they want to market a particular product, right? You will see that, you know, sometimes, you know, they will offer, hey, if you buy Boost, we'll give you something like, you know, we give you a small, pouch of some energy drink, right? So do you think it's all, it's all coming from a well-researched, you know, um, data, right? So they will research all these things, you know, how things are, you know, because they would have studied the association here, right, between the various items in a basket, right? So not only that, even the product placement. So for example, you know, if you go to a supermarket, the product placement, if you see, right, you will see lots and lots of items in in different shelves and all that. You will have different aisles in a big supermarket. If you go there, you will find like milk, okay, then followed by that you will probably find in the proximity, right, you will find some cheese and all those things, correct? It's just not the uh, milk products alone. They also will keep bread close by, right? So there are different theories to that. You know, sometimes, you know, some of the, in order to maximize the sales, they want to, you know, some shops keep the related products because they would have assessed and found out that there is a strong association between milk and cereal, right? So they will keep these two things uh, close by so that the sales actually goes up, right? So the person buys milk, there is an increased likelihood that they will also buy cereal or bread for that matter, right? So this is something they can keep it together. Similarly, they also do, you know, sometimes there is another theory to that. They will keep it very, I mean, further apart, meaning that, you know, somebody who buys milk, right, the cereal is kept deliberately a little far, right? So they know that for sure customer is going to, no matter what, where the product is, the customer is going to take a walk and buy that, right? So they want to also bring various products into the customer's eyes, right? When they walk across the aisle, they may make some impulsive purchases. They may look at, you know, they may just keep looking around for other products, right? They may not look, they may be looking for cereal only, but, you know, they may definitely, you know, take a gaze at some of the other products that are there. That's what the shops want, right? So they want the customers to, they want to influence the customers into making a buy decision, right? So this is all part of association rule mining, friends. There's lots and lots of, the a priori algorithm is one of the most famous one, which is being, which is used here. So this is a very popular one, a very, very interesting thing. In fact, I want to share something, uh, a story which some of you may have heard about it. There is an association of purchase of beer and diaper, right? Beer and diaper. So this is a very classic case of, uh, association rule mining. This is from a very famous story that happened back in early 90s, right? When the retailers researched on the basically the POS data, right? Because those days POS was the, you know, the POS terminals had a large, you know, uh, they were very largely present in most of the supermarkets, right? So it was found, again, there are a couple of theories here. It was found during the weekend. The beer and diaper were always bought together, right? So people are trying to research what is the reason for that, right? So beer is like, people drink and all that, right? Especially the men folks, right? And diaper, again, where is the diaper landing, right? So they, when they researched it, right, what is the relationship here, right? Why is this pattern? So they were trying to research on that. So they found out a couple of two theories which are quite interesting here. The the thing is, like, uh, one is, they say that, the beer drinkers didn't want to curb the enjoyment when they are drinking or watching television. Most likely they'll be watching the television with a drink and all that, especially during a weekend, right? So they they bought diapers in order to reduce the trips to the bathroom, right? This is one of the theories that says that. The other one is like, they the buy diapers, like, this is like, this is for the babies they are talking about, the second one, right? So whenever they go for that, the mothers would generally say they are going on an errand. They say, no, no, go buy the diapers as well. A couple of theories. But if you keep researching on every product, right, you can find a pattern. So this pattern is the one that's a very important, that brings out lots and lots of insights. I talked to you about I mentioned about the product placement. I mentioned about the way they do the promotions, product promotions, all those things. Lots and lots of sciences involved there. Is that clear, friends, so far? Yes? Okay. I mean, others are pretty silent. I think just want to understand others are still there. All right. Okay, couple of folks. Okay, friends. Okay, fine, fine. Thanks. I buy onions and tomato. Yaneshwar says. Okay, that's fine. Yeah. All right. Thanks, friends. So we will move on. So there's lots and lots of association, right? It's a popular, well-researched method for discovering interesting relations between variables in large data, right? So would indicate if the customer buys onions, okay, I think we are getting onions here as well. Potatoes together, likely to buy hamburger meat, right? So that's pretty interesting, right? I mean, the people will also buy this, right? Because they will fry it along with this, the people who bought egg, they will also buy some, onions, right? Especially in Indian, markets and all that, right? So they try to fry it together and all that. There are lots of connections. If you do this, right, this is how they make product promotions and all that, right? So how they, and it is not like, it is not done without any research or anything like that. It's well researched, right? So that's pretty important that way. So number of records, there is something called support and, okay, uh, support, support and, without much thing, right? So I want to say that, the definition is like, support and confidence. These are the two things, and there's one more thing called lift, which is probably not there. Okay, so these are some of the terms that are actually used in the confidence is nothing but, given the person buying something, right? Given the person buying something, buying an item. Let's say the person who is buying orange juice is also buying soda. Okay, or let's take the same example. Given the person buying onion and potatoes together, right? They are also buying hamburger, right? Let's take the same example. So what we are trying to say, confidence is like, given the person who is buying, uh, you know, onion and potatoes together, what is the chance that the customer will buy hamburger also, right? That's the confidence, correct? This is a conditional probability, in other words. So support is nothing but, this is like how many times you see these two products together. When I say this product, right, onions and potatoes together, and also hamburger, how many times, right? So um, so that's lift is another part. Yeah, Nyaneshwar says that. Yeah, that's right. Okay, there is a question here. Will we be able to view this webinar later? Amruta, the point is, this webinar is being recorded, in my opinion. So I think this is recorded and it will also be shared to every one of you, all the participants. So I think you should be fine. Yeah. All right. So let's move on. Okay. Regression. How many people are familiar with regression in any form? Okay. There are few. All right. So let's see what is, okay. There's, so regression, if you look at it, right? So friends, I just want to give you a very simple view of that so that your understanding becomes. So regression is the very, very popular algorithm that is used for prediction and forecasting, right? So you can actually there are different kinds of regression. So if the variable is continuous in nature, right? If the then we can use linear regression. Otherwise, we may need to use logistic regression and all that stuff. There are different um, things available, different kinds of regression techniques, but linear regression is something which is quite popular here. Okay, so regression is nothing but for example, when I'm predicting something, right? There are like I will have a dependent variable and lots of independent variables, right? So when I say dependent variable, right, I just want to give you a very small example. Suppose you want to predict the price of an apartment, right? So when you want to predict the price of an apartment, right? We all come across this question, I mean, this particular thing, right, friends? You all would have encountered. Somebody will come and ask you, hey, what is the square feet area in a particular, locality or location, right? They will say, what is the, and people just say whatever that comes to their mind, at least they will look at some of the things, they say that it's a pretty posh place and that cost, that is like pretty expensive neighborhood, that is an uptown, this is like a, we say all these things, right? So there are different things like that. But if you actually look into that, again, you can predict with fairly accurate things, if you, because there, what can be the prediction factors? You will look at the real estate. If you want to predict the price of an apartment, you will look at things like, you will look at the cost of, the land price, right? That can be one of the factors. You will look at things like, what kind of amenities, right? We in fact ask the real estate guys, right? They say, no, just 2 meters from here is the railway station, like 200 meters you can walk. There is a supermarket and there is something here. They say there is a hospital here and there's very less crime and, there's a fantastic school out here and it's a safe neighborhood. All these are, independent variables, right? All these are like, independent. And what is the dependent one? The price of the apartment, right? So the price of the apartment, in order to predict that, you need all these things, right? For you to make the prediction, right? So you can, the more and more, you apply all these things, right? Then you can come up with a formula, a simple formula, which can somewhat, you can say maybe what is the influence, when you write regression, right? Without going into the math part, I want to tell you like, to what extent the regression, of what extent the independent variables are going to affect the price of the apartment, right? So that's your coefficient, right? So you will have something like a base price, right? In the sense, no matter what, however bad the place is, right? You still need to, you know, for you to buy the apartment, you will still pay some base price, right? So that is your base, plus all the factors which I told you, right? Crime rate, amenities, land price, and uh, proximity to school, all these other things. They all will have some factor into that. The safety aspect could be very high for all you know. And so there are things like, maybe there is a big exhibition hall. That is also one of the factors, but it may not affect much in the whole regression equation, right? So there are ways to arrive at the regression, right? So when you do all these things, right, towards the end, you can even disregard the ones which doesn't influence the price of the apartment significantly, right? So you will not have like 20 things you can come up with, or even more to determine the price of an apartment, right? You will not take all the 20. to compute the regression, right? To come up with the prediction. You will probably take the 6 or 7 significant ones, right? The rest of the things, if they are pretty negligible, you will probably disregard them, right? There are ways to do that, right? So you will take only the ones which are very prominent, which is very significant, right? So they are statistically significant, in other words. Friends, is that clear? Linear regression. I just want you to understand it at a surface level. I don't want you to get apprehensive about regression. It's a very simple thing, and R has got a very easy thing to easy for us to do the prediction. So it's very easy for us to predict given the scenario. If somebody has secured this many marks in the college, in the school, how many marks they would get it in the college, right? So we can do the prediction and compare with the actual values and all that stuff, right? So it's pretty easy that way. Is that clear, friends? Whatever I'm saying? Huge amounts of data. Now, yeah, I mean, the higher the data, the prediction is going to be like, see, initially, it's like this, right? Initially, when I just predict with, 1 or 2 things, right? The accuracy may not be there, but the more and more you do that, right? It is like the model becomes more firm, right? Okay, there is a question. Yeah, what is the simple books to learn statistics? Yaneshwar, I would say, don't go by I mean, there are ways to do statistics, but I would say, go to, if you are taking up a course with Edureka, they give a primer course in statistics. But, I'm not telling you to take up the course or anything, but, it is your choice. But Edureka gives a primer. But if you're looking at other options, I think you can probably try out Khan Academy. Khan Academy has got a very good, statistics thing as well. There are myriads of sources. Khan Academy is pretty good that way. All right. So just moving on. K means clustering. Before that, there's one more question here from Pratik. The question might be out of place. Shall we ever? Okay. How do we decide for a data? No, linear regression, Pratik, as I said, right? If the dependent variable, if it is not a yes or no decision, right? Dependent variable, the price of an apartment, it is continuous in nature, right? So it is not categorical, it is continuous in nature, then I go for linear regression. Anything that is continuous, right, I'll go for linear regression. Does that make it clear? So suppose if will it rain tomorrow? Yes or no, right? So I cannot have linear regression here, right? It's more a conditional thing. So it's more I would rather go for logistic. So there are different regression techniques which I should be using here. Pratik, does it make sense? Sure, welcome. K means clustering. Okay, this is, I don't know how many, we are on the slide 30. So K means clustering. This is one of the beautiful techniques we have, right? So this is like what we are saying is objects are classified into groups as much dissimilar as possible from one group to another, but as much similar as possible within each group. So can you think of any examples in this thing, friends? Clustering. Has anyone heard about it? Some of you may have, but okay. Clustering is nothing but grouping some of the pockets, right? Grouping. When you say cluster, right? Cluster is nothing but a group, right? So we group the ones which are homogeneous in nature, right? Something that is similar, correct? So we don't group the ones that are very dissimilar, right? So that means they need to be in different clusters, right, friends? See, suppose I want to group, let's say, in an organization, I want to, probably I'll be showing the same example here as well, when I show you the lab session. In an organization, I want to keep a group, right? What do we do? I mean, why we need to group? Because we always have, like, there are a lot of HR policies we have in an organization, right? So HR policy will not be for an individual generally, right? We don't, you know, the policy is never for an individual. It is for a cluster, correct? So when I say cluster, they will announce generally after the appraisal cycle ends and all that days, come back and announce, hey, I'm going to give you like, you know, 20% raise for the top 5% performers, right? So they are given a significant raise. Then I want to give like, you know, maybe 10% raise for the other 50% people who are like medium, right? And you know, there is another like 5% for the, you know, the people who kind of met some expectations, right? And the last one is like, you know, they are generally, you know, they are sent to training or they are laid off, whatever, right? So the HR policy, and how do they do? These are all the clusters again, right? Top performers, top 5%, bottom 5%, the next 20%, whatever. These are all clusters. And how do they cluster? They should have something very similar, right? That's what we are saying. They are as the clusters per se, which is like, you know, top performers versus medium performers, they should be as much dissimilar as possible from one group to another, right? They should be, right? Whereas much similar possible within each group, right? If I have a cluster of top performers, I should not have like, you know, one high performer and one dumbo in that group, right? I should have some, you know, I should have a group which has got all the experts in that, right? So that forms the cluster. So they are very similar in their attributes. Similarly, they will be extremely dissimilar from the people who are just average folks, right? They are dissimilar. So this is something I want you to understand. Let's say bucketization. Yeah, correct. Arun, that's like a bucketization. Correct? Yeah, correct. So Banu says like from apple and orange. Yeah, that's correct. It's like, you know, distinct buckets, and within that you have homogeneous elements in that, right? That's what we are saying. Should be group one should be similar as possible, but should be much difference between objects in different groups. That's what we are saying. The attributes are not allowed to determine which object should be grouped together. Okay, so we are moving to the hands-on part, friends. Friends, is that clear? The definition of, and K-means is a clustering technique, right? So what we saw is the cluster definition. K-means is nothing but a clustering technique. So I'll show you a simple lab part. I think we are like, probably, you know, we may have, I just want you to bear for another 5-10 minutes or something if I can close it. Okay. Just a minute, friends. I'll just move on to the labs. So yeah, I'll move on to the labs, friends, from here. But you know, I just want to thank you for, you know, for your time. Otherwise, so I'll close it with the lab after this, right? So I mean, the deck also clearly says recording and the presentation will be made available to you within 24 hours. So I think this is fine. So I think this is probably the last slide. So I'll close this deck. I'll move on to the, you know, I've opened RStudio here. I put some information so that, you know, the lab can be, you know, what we are saying, you're saying like, you know, 25 people, extremely homogeneous nature. There is like intra-cluster similarity should be there. Intra-cluster is within the cluster, right? Inter-cluster should be, you know, very distinct, low performers versus medium performers, high performers, right? So there's a very clear, you know, distinct similarity, right? Sorry, it is very, very distinct, I would say. So there's a lot of distance between a high performer versus vis-a-vis a low performer. Whereas within high performers, they are very, very similar. That's what we are trying to say. So number of clusters is what we mean by K. So what we are trying to say, I'll just show you the data set, friends, to start with. I have workers.txt. So, okay, I'll just show you the file, data set. Workers.txt. This is what I have, right? So what I have here is like, you know, I have like 50 workers and they have scores, right? So 93.12, okay, I have a question here. Sorry about that. So I'll just quickly answer this. Decision tree, linear regression, we saw a random forest, and We saw association mining, and this is the k-means. Jaya, does it answer your question? Okay, all right. So score, we have like 93, 94, and some of them have scored 78, 69, and all those things, right? So now we need to make clusters so that we separate out who is the cream versus who is the best, I mean who is the cream versus who are the next best, and who are the just about ordinary, and who are probably not so good, right? So again, I think someone asked me in the beginning, right, how do you determine which is the root node in the decision tree? Similarly, there is a way to even determine what is the best, how many clusters you can have, right? So somebody may have like 5 clusters versus 10 clusters versus whatever. If I'm going to create 50 clusters here, right, that's going to be completely useless here, right? So I need to have meaningful number of clusters. At the same time, I cannot have only 2 clusters. That's not going to be very helpful either, right? Because there are different ranges of data here. So you need to form meaningful number of clusters, right, friends? So this is my data set. So I want to first show you in R, I'm reading the database, the data set here into a variable, which is my, just using read table. So this is where my, it's separated by a tab, and, I'm giving, there is a header available for that, right? ID, whatever, score. Okay. So I'm saying that, so look at that. I'm sorry, here. Okay. That is red. And the next thing is, okay, I'll clean up this place 1 second. Okay. And going back to this, so let me execute it again so that it's very clear. And so this one, so there is something called the elbow curve. I think you will, I don't want to go into the details here. So the elbow curve, this is like number of clusters, right? If I do this, right, so if I do the if I try to use the k-means here, right, I can at least, before applying the k-means, I should know how many number of clusters I can have. So it is not possible for us to just look at the data and determine. So there is a way to do that. So this is like group sum of squares and number of clusters. So from this diagram, friends, I will zoom it, I'll just zoom it. How many clusters do you think makes it very ideal? Okay, some are saying 10, some are saying 2. Okay, Indra says 5. Why would you say that, Indra? Any reasons for that? Excuse me. Why would you say 5 here? Which I feel is you're almost there. Why would you say 5? Any reasons for that? Okay. Well, friends, the thing is pretty simple, right? Indra has mentioned 5. I would say even 6 is in the vertical line. Okay, see, if you see the elbow curve, right, this is like an elbow, by the way, right? It's called the elbow curve. You actually see this is actually getting flattened out, right, at this point, right? So this intersection can be the ideal number of clusters, right? Okay, so 5 after that also, 5 is also kind of okay because it flattens out here. It's almost like, correct? So we are trying to plot it here, like, we are saying, we took, if you see this, right, we are saying 1 to 15, right? We just plotted it. So at 5 itself, it is kind of straightening out, flattening out, right? So we can probably take 5 as the 4 or 5 as the, number of clusters we can have, right? Right? So now k-means, I don't need to do anything in R. It simply does the k-means for us. So if I do this, right, if I do this, and if I print this, so it says 1 1 2 1 1. So can you tell me, friends, what is this, by the way? What is this? Okay, sure, Indra. I think Indra, fantastic. Yeah, I mean, your guess was spot on. So this is what, friends? Jnaneshwar says cluster ID, right? So I am saying 4. Say it is plotting 1 1 1 1 2 2. If you look at the data set, right? 1 1. If you look at this, right? It has put all this in one. The first 4 things, right? Into 1 2 2. Look at this, right? The clusters, they are actually coming in like, 2 2 1 1 1. It is like grouping them. This is like a cluster ID for me, right? So I want to show you a simple, before that I also want to show you one more thing, right? If I see just this, right, it also tells what are all the, what is my accuracy is like about 90%, right? So I can try with more 5 and all that. The accuracy is higher, right? Because if I'm going to give just 1, right, the accuracy falls down dramatically, right? So I'm going to give something meaningful, so which I can determine using the elbow curve, right? So it says cluster centers, total SS, within SS is the intra-cluster, right? Correct? So these are some of the, between SS is the intercluster. I don't want you to remember everything. So these are the significant ones, right? So the k-means, how it works is, friends. So initially, when the k-means, like, if you need to cluster, right, friends, even the system, how it works is, if I want to create four clusters, right? If even if the HR wants to create 4 clusters, they will probably form 4 groups. Let's say experts, and let's say medium performers, and let's say average performers, and let's say bottom most performers, right? And they may, with some basic knowledge, they may try to fit in people, right? And maybe, over a period of time, let's say, initially, let's say all of them are put into some training, right? Day number 1, people are largely quiet, right? So they may try to plot the people who asked the questions, right? A couple of people who opened up a little bit. Now they may try to put them in the expert, for all you know. And as the training progressed, I'm just saying a simple example here. As the training progressed, right? Some of the silent guys, right? They are extremely good in algo and all that, right? Now, and they are solving, and they don't talk much, but they are very efficient, or very good in their work. So they become experts. So similarly, you try to shuffle them, right? You try to shuffle them until you are very convinced that all of them have gone into the proper cluster, right? So that level of thing has to be done, correct? Similarly, and how do you need to make a start somewhere, right? So similar, and these are called centroids, right? So let's say I want to create 4 clusters. I'll put some dots, in my graph at some point, right? I'll put it, and I'll try to align all the elements which are there in me, all the data points, right? Let's say the ID, I have the score, ID and the score. I have like 50 score available, right? So I'll try to shuffle them into different clusters. Then I try to make it as homogeneous as possible within each cluster, and as dissimilar as possible, between a cluster, right? Once, I try to move the centroid every time. The centroid is the center point, right? Center point is like a point, right? So that keeps shifting gradually. So then after everything is done, right, at some point it stops. There's nothing to be moved. That's when we stop making this, and and we have perfectly formed clusters, correct? So I'll show you a simple, how do we decide centroid? No, Jaya, the point is, how do we decide? Decide, it is done at a very random fashion, Jaya. So then you will see the centroid itself keep shifting. Then all the data elements, right? We try to make it, because anything can be a centroid. Then we try to move the centroid also, so that data points can be collated, so that we form a proper cluster, correct? I'll show you animation. Just give me a data. If I have, like, for example, I'll show you a simple. This one is what we did, right? So now I will do the animation here, correct? So now I'll show you the animation right now. Um, you see this now. Oh, you can't see it here. I'm sorry. You see this, friends? Centroid keeps shifting. These are all centroids, right? 1, 2, 3. So it keeps shifting so that it's trying to form a perfect cluster. See, it probably made, we are trying to give 4 clusters, but it would have made few iterations. Let me do it again so that you can actually appreciate what I'm trying to say. Is that something I can zoom it and see? Okay, now it is like perfectly formed cluster. Yeah. So, and you can, I can also do something like, I can put a data, I can assign to a variable on this, and if you see this, right, I can put the cluster information, right, against each record. Sorry, and I can plot this as well, right? So this is, I can plot the, see, look at this, right? This is what I try to plot. With the cluster information, right? I have plotted, right? And if you see those red ones, they're all here. The blue ones are here. There's a green one and there's a black one, right? There are four clusters which we try to plot here. Correct, friends? So, just a second. And if you want to look at the structure, you can also look into the k-means, whatever that we have arrived, right? So these are all the ones, and yeah, this is something which we already saw. Okay, so friends, I think this is what I wanted to show you at just the base, the how we execute the k-means. It's a very powerful algorithm, and there is a question from Amruta. Data set as categorical. Um, uh, Categorical and continuous variables. Does k-means accept the data set? It can accept categorical as well. I haven't come up with a combination, Amruta, but there should be a way to address this. I'm sure about that. There should be a way, I guess. Yeah. Can I see the data map to which dot? Example, what is the data for red date? Okay. Red is, somewhere in the range of Yaneshwar. It's somewhere in this range, right? So this is what? And this is the blue, and this is the green, and this is the black. So red is somewhere in the range of 60s and all that. Correct. So that's what we have. So if I look into this, right? If I look into this, just a second, let's look into the data set. So let's say 68. So this is my, approximately this is my thing, 68, 60, all those things. They are all the red ones. I'm sorry, friends. Couple of questions here. Because we apply k-means for telecom churn prediction, okay? This data set will have customer information as categorical and continuous. So didn't understand how to apply in this case. You will have both coming, Amruta, in this case. Customer information, which is okay. Okay, I need to see this, Amruta. I haven't, I don't want to give a random answer, but you can definitely address both, and that should be a way to do that. I just that I haven't done it here, but you can probably, you can make the categorical one as, you can probably, uh, what I'm thinking is, you can get a, the respective, you can get a factor variable out of that. Maybe that is one way I'm thinking. Categorical to factor. That's what I'm thinking, Amruta. Yeah. That should solve your problem. Maybe here. Yeah. Okay. So, Jnaneshwar, are you okay too? Red is in which cluster? I mean, did I answer your question, Jnaneshwar? All right, fine. So, friends, any other questions? If you have, otherwise, I'm done pretty much. Okay, Jnaneshwar is having a question. Okay, definitely. What kind of interview questions will be on clustering? So interview question, in fact, personally, I have asked this friends. A lot of people know about k-means clustering, right? That's something, they will definitely tell. But my point is like, how do we determine, for example, a lot of people will not know what is the ideal way, what is the ideal number of clusters I should have, right? So this is elbow curve is one thing, but that is something you need to you know um, you need to understand the basics very clearly, because it's just not enough for you to just know the mechanics of clustering. Like how do we even do clustering, right? I think churn prediction Amruta is asking, right? There are so many things people do clustering, like predicting the you know they even predict crime rate and all that. They predict what can be the number of fatalities in accidents. So many things, they do clustering techniques, right? So uh, then book to improve statistical mathematics. So Banu, as I said, there are lots and lots of books. I don't know which one to say. I personally, for you to get things quickly, you would rather go and listen to something, or start off with maybe looking at some primer course in statistics. A lot of online courses are there, Banu, right? Just give it a shot on that. Some MOOC, yeah. MOOC is there, plus, or take up statistical from Khan Academy. That's what I was trying to suggest, because I found a lot of cool things, concept by concept in Khan Academy. So that is pretty easy to grasp it. They simply do a whiteboarding part, which is easy to understand, right? Instead of, because I'm not a big believer of thick books, and you'll never, you will end up nowhere. That's what I feel. So coming back to Jnaneshwar's question, red belongs to which cluster? 1, 2, 3, 4. Okay, we will see that, right, Jnaneshwar? Like, let's say, I'll quickly do that. Uh, you know, the data set, what we saw here, D1, let me look at the data set here. 22, for example, right, which is, let's say, 68 is also red, 6, right, which belongs to cluster number 2. That's it. Right? So that's pretty simple. Okay, so that's easy, friends. Yeah. All right. So, friends, thanks for taking your time, to attend this. Hope you found it useful. I was very, I learned quite a few things from your questions. So, thank you so much, and thanks for being extremely patient. And good luck for everything for you. And you should have the recording maybe within 24 hours. So look forward to have you in a different webinar pretty soon. Thank you so much, friends. You have a wonderful night, and great day for the people from the other side of the geography. Thank you so much. And please feel free, please do it in the, remember to do the feedback, right? So I'm from India, friends. Yeah. Thank you so much.